Hello, my name is Chris Harding. I'm a chemical engineer and biological scientist, and I was at Jack Welch Management Institute, where I was an honor student, which is exceeding MBA standards, meaning I had the ability to go on to PhD possibly for a business, but I didn't want to. Harvard was interested in me. Jack Welch Management Institute was interested in me. I'm affiliated in MIT. I'm a friend of John Hopkins. And the reason why I'm telling you this, because I am an ex-NSA CIA FBI employee, and I was a profiler of pedophiles, and I also was a code reader. The NSA turned their back on me after I profiled many members of corporate America and Congress as pedophiles, and I'm talking about corporate leadership. So I now work playing around with computational fluid dynamics. And I took computational fluid dynamics from supercomputers down to the cell and with my mathematical derivations. I'm not lying. And you can actually go to Chris Harding, LinkedIn. You look at my work, and this is succinct work. I actually posted one that's a wake bubble, and it's a wake bubble on a human body. And I've been told, I don't know if it's true, but AI said that it's common for a wake bubble to be created after a direct numerical simulation, which is the most advanced simulation available. And that takes time. My simulation actually is more efficient, and actually my code is more efficient, and it actually does the derivation of the wake bubble on streamlines in about an hour and 4 minutes. Now, I know a little bit about computational fluid, but I know a lot about calculus. And I'm not as strong in calculus as I was, but I'm affiliated with MIT because of my mathematics calculus. And the dean of mathematics had approved me according to the internet. So I don't have a degree. I don't have a micromaster's. I'm a pretty rare person. I have a BS in chemical engineering. So I want people to potentially go to Chris Harding, LinkedIn, and download the documents, or they can also go to GitHub, Happy S5, and look at the actual code and run it on their computer, on not their computer or their cell phone. I suggest you try the cell phone because the cell phone doesn't get hot, doesn't burn it up. It's very efficient code. The way it works is I morph geometry. I have a sectional sweeping polygon morph integral, and that's what I have. What that is imagine a polygon two-dimensional, and there's normal vectors coming out of the center of gravity of each triangle that fills that polygon. And there's n triangles, and n approaches 0, and that means it takes up the space of the triangle. And they don't go to reach 0, so that means as a triangle approaches 0, more triangles take a position. So right n number of triangles can go to infinity.